Okay, here's a quick video on Doppler effect for those who missed it. Doppler effect is an apparent shift in the frequency for a sound wave produced by a moving source. That's the definition. I think you'll understand it a little bit more if I give you an image. So here I have a fire truck. The fire truck is at rest, and then I have a person here, a woman, and I have a man here. They are equidistant, or they are one's in front and one's in back. Alright, so sound, as mentioned before, sound will be put out as a sphere. So it goes out in all directions. And since the speed of the sound is dependent on the medium, in our case which is air, it goes out in all directions at the same speed. Since it goes out in the same speed, if I have a set frequency that is being emitted by the truck, let's say 1600 hertz, then the wavelength, the distance from here to here, or the distance from here to here, distance from here to here, it's all the same. So the person in front and the person back hear the same frequency. Nothing has changed. Alright, so let's say the truck is moving. Well, if the truck is moving, that means the truck will put out a sound, and then as the sound travels, it physically moves closer to the wave it just put out, then puts out another one. So this person here is hearing waves come a lot faster than this person here, who those waves are reaching him a lot slower. And the amount of compressions in a second is called the frequency. So the more compressions that meet this woman in a second, the higher the frequency she hears. And this guy, the lower the compressions he hears in a second, the lower the frequency he hears. So it's not that the truck put out two different sounds. The truck didn't. The truck put out one frequency, and then it manipulated those wavelengths by physically moving its position, either compressing the wavelengths or making the wavelengths longer. If you compress the wavelengths, if this number gets smaller, that means this number has got to get bigger, which means this person hears a higher pitch. If this number gets longer, if wavelength gets longer, that means frequency has to get lower, and he hears a lower pitch. So that's what Doppler effect is. It's a perceived change in the pitch, because there was a physical manipulation of the wavelength. And if you manipulate the wavelength, then you change the frequency as well. Alright, so for Doppler effect, you'll find a couple of different formulas online or in a textbook, but I like one, and then I have some sign conventions that you use. So the equation is F prime, and that stands for the frequency that you hear. That equals FO, and this stands for the frequency that's omitted, the true frequency put out by the truck or the horn or the siren or whatever is making the sound. And this is V plus VO and V minus VS. So V is the speed of sound. VO is the speed of the observer, who's hearing the sound. VS is the speed of the source, what's putting the sound out, what's the source of the sound. So that's what these variables stand for. This is what you hear, this is what's omitted, this is the speed of the sound in air, which is 343 for the most part. This is the velocity of the observer. Is the observer moving? Is the observer not moving? This is the source. Is the source moving? Is the source not moving? So not only do you have to consider if these things, if the observer and the source are moving, but you have to consider how they're moving. So there's a sign convention, and it's pretty simple. Toward, the sign is positive on the velocity. Away, the sign is negative on the velocity. Alright, so that's our sign conventions. Let me give you an example here. Let's go back to the fire truck. Alright, so let's say I have a fire truck here, and the fire truck puts out 810 hertz. That's the frequency that's coming off the fire truck. And let's say the velocity of the fire truck is 45 meters per second. Okay? She's still and he's still. So let's figure out what she's hearing. Well, since the truck is moving toward her, the wavelengths are going to get smaller, so she's going to hear a higher pitch. Alright, so let me fix this a little bit. There we go. So let's have our equation. So what does she hear? What is F prime? F naught V plus VO over V minus VS, velocity of the source. Now these signs stay in the equation. The plus and minus for toward and away get attached to the velocity. So let me go ahead and figure this out. So the frequency observed, or the frequency omitted, is 810 hertz. The speed of sound in air is 343 plus, down here, 343 minus. So the observer, what's the velocity of the observer? Well, she's not moving, so that'd be 0. And the source, is the source going toward or away from the observer? In this case, the source is going toward the observer, so the velocity of the source is 45, so I will keep it 45. So if it's 343 divided by 343 minus 45. This minus stays with the equation, but the speed of the source was positive, so I put that number in as positive. So let's take a look at this guy here. Again, I have that same equation. 810 is what's put off by the fire truck. This observer, again, is 0, because he's not moving. And then the velocity of the source, that's minus. Oops, I put a 0 in there too soon. But we're still in the rest. So 810, 343 plus 0 over 343 minus. Now, is the source going toward or away from this observer? It's going away. And according to our sign convention, away is negative. So that'd be minus a minus 45. And when we do the math, we should hear something lower than 810, and over here you should hear something higher than 810. Well, let's try this one up here. Let's assume she's moving this way towards the fire truck, and the fire truck is moving that way towards her. So I'll use my equation. F prime is F naught. I'll squeeze this in. V plus VO over V minus VS. I'm going to squeeze that in right there. Sorry, so floppy, but I'm doing this on the fly. So I have 810, 343 plus, and then I'll put my 343 minus down here. Alright, so she's moving this way. She's moving toward the source. Toward is positive. So let's say she's moving at 10 meters per second, and we'll make him go 45, the same as below. So since she's going toward the truck, the observer is going toward the truck. Toward is positive, so that's a positive 10. The truck is going toward her. Since toward is positive, that's 45. So if you look at the equation, you have a plus 10 on top and a minus 45 on the bottom. Remember, this plus and minus stay in the equation. All right? And so you can see where the toward and away come from. If you keep in mind, when you're doing toward and away, you have to look how they're moving in relationship to each other. Take it one step at a time. See which way the observer is moving in comparison to the source, then see which way the source is moving in comparison to the observer. If you keep that in mind along with the sign conventions, you should be okay. So I hope this helps, and I will link it to the calendar, and you all can look for it there.